Okay, let's learn how to evaluate trig functions for angles that are given on the unit circle. You'll want to make sure you have a copy of your unit circle handy because we're going to need to refer to this in order to answer the questions on the page in our notes. First of all, there's some steps right here at the top right corner. To locate, first thing we need to do is to locate the angle measure on the unit circle that we're being asked to find. And let's start here with number 1. It asks us to find the sine of 90 degrees. So we need to go to our unit circle and locate 90 degrees, and then we want to find the sine value. The sine value is going to be the y value of whatever coordinate we see at 90 degrees. So go over to the unit circle, 90 degrees, up here at the top, find the coordinate, and the y coordinate is the value of sine. Now that we've gotten our unit circle established, all the coordinates are actually going to be the cosine and sine of each given angle all the way around the unit circle. Sine is always the y coordinate, cosine is always the x coordinate. So the sine of 90 degrees is 1. Okay, number 2 asks for the sine of pi. Pi is my angle measure. I need to go to my unit circle and find pi, and then look for the y coordinate. Here's the angle pi, and the y coordinate is 0. So the sine of pi is 0. Alright, the next two examples are asking us to find cosine. Number 3 says we need to find the cosine of 5 pi over 6. So I need to go to my unit circle and look for this angle, 5 pi over 6. Unit circle, locate 5 pi over 6. Remember, 5 pi over 6 is an angle measure. It's in radians, but it's congruent to 150 degrees. 5 pi over 6, they asked us to find the cosine. The cosine is the x coordinate. So the cosine is negative root 3 over 2. Okay, number 4. Number 4, we are asked to find the cosine of 7 pi over 4. Go to my unit circle, locate 7 pi over 4. That's an angle given in radians. And 7 pi over 4 is down here in quadrant 4. I was asked to find the cosine. The cosine is always the x coordinate. So the cosine is root 2 over 2. Okay, so let's pause the video for a moment and you do the next two. You find the answers for number 5 and number 6. Okay. You'll continue to locate the sine and cosine values using the unit circle, and then the next trig function we want to be able to evaluate using the unit circle will be tangent. In order to find the tangent, we're going to need to do some fraction division. So let's take a look at how to divide fractions. This is a little bit of a refresher on fraction division before we get ready to find our tangent values. This example here is dividing fractions. It says 3/2 divided by 2/3. Either way, it can be written 3/2 divided by 2/3. In order to do division, I keep the first fraction, I change the multiplication, I change the division to multiplication, and then I flip the second fraction. I find its reciprocal. So the way I'll do this is keep the first fraction, change this division to multiplication, and flip the second fraction, find its reciprocal. Then I simply multiply straight across the top, multiply straight across the bottom, and simplify your fraction if you need to. This one does not need any simplifying. It is in simplest form, and we prefer the improper fraction form, so it's best to leave it just like that. No need to get a decimal, no need to write a mixed number. Write it exactly like this, 9/4. Go to the next example, example number 2. Dividing these fractions. The square root of 2/2 is being divided by itself. Anytime you divide a fraction by yourself, your answer is always going to be equal to 1. A fraction divided by itself is no different. The answer is 1. Example 3. 1/2 divided by √3/2. 1/2 divided by √3/2. I need to keep, change, and flip. Keep the 1/2, change the division to multiplication, and flip the denominator. Now multiply straight across the top, multiply straight across the denominators, and I would be finished here if I didn't have this special circumstance. In the denominator, there's a radical. The square root of 3 is in the denominator, and that is not allowed. That's not allowed for me to leave my answer in this form. I cannot leave my answer with a radical in the denominator of a fraction. So I have to go through a process of getting rid of that. I have to eliminate the square root of 3 that's in the denominator. So I'm going to take my answer, 2/2 on the square root of 3. Now the first thing I would do is recognize that those 2's will cancel each other out. The 2/2 is equivalent to 1. So these cancel each other out, and I'm just left with 1 over the square root of 3. So that kind of simplifies our fraction a little bit. Now I still need to do the rationalizing. It's called rationalizing the denominator. Whatever is in the denominator, I want to multiply the top and the bottom both by that radical. Square root of 3 over square root of 3 is a form of 1, and so that's what makes it legal for me to be able to do this. And by doing this, I'm getting rid of the radical that's in the denominator. The square root of 3 times the square root of 3 ends up being just the number 3. The reason for that is because I really get the square root of 9 when I multiply those two denominators together, and the square root of 9 is equal to 3. So this part right here is actually my final answer for number 3. Now that I've done a little bit of extra work, I've found my final answer there. The next two obviously do not have fractions in them, but they are special circumstances. 1 divided by 0. This is what we would call undefined. You are never allowed to have 0 in the denominator of a fraction. See, all of these rules that we learned before in previous courses, we have to remember all of these rules in pre-calculus and apply all of them with the different topics that we're learning. 0 is never allowed in the denominator of a fraction. In mathematics, we call that undefined. So we write out the word undefined. That's my answer. 1 divided by 0 is not defined. 0 divided by 1, however, that is equal to 0. 0 divided by 1 is equal to 0. If you ever forget which of these is undefined and which is 0, you can always use your calculator as a tool to help you, because if 0 is in the denominator, the calculator gives you an error message. You can't do it. It tells you it's undefined. But if you put 0 divided by 1 into the calculator, it will tell you the solution is 0. Okay, we need to use those skills in order to move forward and be able to find the tangent of our angle measures. Okay, finding tangent using angles on the unit circle. We've already established that every coordinate around the unit circle has the cosine of that angle value as its x-coordinate, and the sine of that angle value is its y-coordinate. We use a combination of those two to get the tangent. The way we find tangent is we divide the sine by the cosine. To find the tangent, we have to take the sine value and divide it by its cosine, or in other words, the y-coordinate divided by the x-coordinate. Both of these are true. So in order to find the tangent of pi over 6, I need to go to my unit circle and get the sine and cosine values at pi over 6. So let's go over to the unit circle, find pi over 6, find pi over 6, which is here. The sine is 1/2. The cosine is root 3 over 2. So now I go over to my paper again and I can write the sine is 1/2 divided by the cosine, which is root 3 over 2. So now this is where I'm going to use my division rules. So I'm going to have 1/2 times 2 over root 3. Notice here that these 2's are going to cancel each other out, and so that leaves me with 1 over the square root of 3, which is just like we had in one of our examples. I can't leave it like that. I can't leave it as 1 over the square root of 3. That would be incorrect. I'm going to have to get rid of the radical in the denominator. So I have to rationalize the denominator. When I do that, I get the square root of 3 over 3. This is my tangent of pi over 6. Okay, let's do the same thing for number 2. This time we want to find the tangent of pi over 4. So go to the unit circle, find pi over 4. Here we are at pi over 4, and we need the sine divided by the cosine. So at pi over 4, I've got the same value as my sine and my cosine. That's kind of a good thing, because that's going to mean less work for me. So it means it's square root of 2 over 2 in the numerator as well as in the denominator. It's the exact same fraction on the top and the bottom. So if I'm dividing something by its exact self, that will always be equal to 1. So the tangent at pi over 4 is equal to 1. Okay, let's do one more together. Let's do pi over 3. Go to the unit circle, find pi over 3. It's right here, pi over 3. This is my sine. I need to divide it by the cosine. Okay, go through my division process. Keep, change, flip. Notice you've got some repeating values there that are going to cancel out. Square root of 3 over 1. So my final answer for the tangent at pi over 3 is the square root of 3. Okay, so you're going to go ahead and continue to find each of the tangent values, and then when you do, you're going to write them on the unit circle that's next. So we've found these 3 tangents. Let's go ahead and put them onto our unit circle. We found that this is 1 and this is the square root of 3. So when you find each of the tangents, enter them into the boxes, and then that way you'll have a complete circle with all the tangent values on it, and that's going to be really helpful for your unit circle project.